Points in the plane. Now that we've recognised the prevalence of points, lines and curves in the world in which we live, and the ways in which they can appear in science and engineering problems, we come on to the task of trying to define and describe them mathematically. We have seen that points are important because they help us to define straight lines. Let us see how we can be more precise about what we mean by a point. Mathematically, a point is a location or a place. If we take a sheet of paper, we can draw lots of points upon it, as shown by the bullet symbols. In a mathematical context, we often refer to a flat sheet like this as a plane. We refer to these points lying in the plane, or simply points in the plane. We can see where these points are, but we've no way yet of specifying their precise location. We might choose to label some of the points so that we know which ones we're referring to. We've labelled two of the points P and Q, but we still don't have a precise description of where they are. What we need is a reference system. There are many possibilities, but one way is to draw in two axes. The axes are straight lines at right angles, that is at 90 degrees to each other. It's conventional to name and label the axis which runs from the left to the right as the x-axis or horizontal axis. Notice the direction implied by the arrowhead. Similarly, it's conventional to name and label the axis which runs from bottom to top, the y-axis or vertical axis. For the purposes of this introduction, we've used different colours to indicate the two axes. Some students find this a helpful way of distinguishing them when they first start. We'll discontinue this practice shortly. When we start to use these techniques in scientific and engineering applications, we might choose to label the axes in different ways. For example, it's commonly the case that we want to use the horizontal axis to represent time, in which case the horizontal axis might be referred to as the t-axis. For now, we'll stick with x and y. The point where the axes cross is called the origin, and we usually label it O. Notice that the two axes divide the plane into four distinct sections. We call these the first, second, third and fourth quadrants. Every point in the plane lies in one of these quadrants or on the axes. Now at least we know which quadrant each of our points lies in, or which axis it lies on. But this is still not precise enough to tell us exactly where the points are. What we can do though is measure the distance from a point, such as Q, to both the horizontal axis and to the vertical axis. These two measurements, along with knowledge of the specific quadrant that the point lies in, is sufficient to give us the precise location of the point. To measure the distance to each of the axes, we draw on each of them a scale of measurement. It is conventional to draw the scale on the x-axis as a number line from negative on the left to positive on the right. Similarly, we draw the scale on the y-axis as a number line from negative at the bottom to positive at the top. The axes usually cross at the 0 point on each axis. Choosing to use the scale in this way means that every point in the plane can be described uniquely, as we shall see. We see that the point Q is a horizontal distance 9 units from the y-axis and a vertical distance 5 units from the x-axis. This horizontal distance 9 is called the x-coordinate of Q, and the vertical distance 5 is called the y-coordinate of Q. Together these numbers are called the coordinates of Q, and we write these concisely as Q brackets 9, 5. We say that the coordinates of the point Q are 9, 5. The y-coordinate of a point below the horizontal axis is negative. The negative sign indicates to us that the point lies below the axis. The x-coordinate of a point to the left of the vertical axis is also negative. Note that this convention is consistent with the negative numbers on the axes. The horizontal or x distance of P is 3, so x is 3.
The vertical or y distance of P is 1. But P lies below the horizontal axis, so its y-coordinate is -1. So y equals -1. P is therefore written as P 3 minus 1. The coordinates of P are 3 minus 1.
In summary, by drawing horizontal and vertical axes and choosing a suitable scale, we can specify the exact position of any point in the plane of the paper by giving its x and y coordinates in the form xy. Finally, you should be aware that this particular way of describing the location of a point is due to the French mathematician Descartes, and because of this we sometimes refer to xy as the Cartesian coordinates of a point.